I am going to take lecture on the heat and mass transfer. I am Dr.Senthilkumar, Associate Professor, Department of Mechanical Engineering. I am having over 20 years of teaching experience. In that, 10 years of experience in heat and mass transfer specifically. So, in this subject, heat and mass transfer is a very essential subject for mechanical engineers. In the gate question also, there will be one or two questions will be appearing in the case of heat and mass transfer. So, when you study about the heat and mass transfer, you must know what are the modes of heat transfer. There are three modes of heat transfer are there. One is conduction, another is conduction, another is radiation. So, conduction is the first mode of heat transfer, conduction is the second mode of heat transfer, radiation is the third mode of heat transfer. So, when you understand the mode of heat transfer, then only you are able to study the subject such a way that the structure of the course also formulated based on the conduction, convection and radiation. The last unit is supposed to be mass transfer. To understand the mass transfer, when you are keeping a coffee, hot coffee on the table, after a certain amount of time, you can see there is some reduction of volume of the coffee. The vapor which is transferred from the coffee region to the ambient region. So there is a transfer of vapor form. So in our body also, biological heat transfer, we are taking food, the volume is getting vanished and is becoming as a liquid. The solid which is becoming as a liquid, as a blood, which is traveling throughout our body, maintaining our body. That is an example for mass transfer. And heat transfer, these three modes of heat transfers are there. Now, coming to the conduction, can anyone say what is the conduction? Where it happens? How it happens? Law associated with conduction. Law associated with conduction.
Fourier's
heat law of conduction. Very good. So, Fourier law of heat conduction is associated with the conduction. So, it happens due to lattice vibration. It happens due to lattice vibration and which follows the Fourier law of heat conduction. Fourier law of heat conduction. What is Fourier law of heat conduction? Q equal to
minus
AA
into
dt by ds. Where this minus sign indicates when heat is traveling from this point to this point, for example, one point to another point, it will always get reduced 70, 60, 40, 80. That indication is indicated here in the formula by the Fourier as minus. K is associated with the materials. So that is thermal conductivity, watts per meter Kelvin. Watts per meter Kelvin. So it is assumed that the most of the conduction heat transfer takes place in the metals in contact, which can be witnessed in the metals which are in contact. It happens in fluid also, but it can be visualized in the metals due to lattice vibration of individual molecule which is present in the metal. So this is about the conduction. So when you go into cooking area, you are warming a milk, that pan is there, that pan which takes the heat from the source and transfers heat throughout this pan. So this is called as a conduction. That is called as a conduction. Easily you can understand. Coming to the conduction, next mode of heat transfer. Conduction is nothing but transfer of heat from one point to another point in a fluid region, in a vapor region. So we can say the conduction happens in the fluid in indirect contact. Indirect contact. The law associated with this conduction of heat transfer is Newton's law of cooling. Newton's law of cooling. Here the formula is Q equal to HA delta T. This H is nothing but heat transfer coefficient. The conduction mode of heat transfer is measured by heat transfer coefficient H. which is acting the unit of watt per meter square Kelvin. Watt per meter square Kelvin. It happens mostly in fluids or in vapor form. When you are cooking a water, there you can see the boiled form of water which is moving upward due to buoyancy force. You can see the balloon which is floating on the air. Because of its lower density, air is more denser than the balloon which is filled with the gas. So that is part of the buoyancy effect. So opposite to the gravitation. Buoyancy is opposite to the gravitation. Coming to the next mode of heat transfer, which is nothing but radiation, which happens without any contact. No contact. Or we can say no medium. There is not any medium. So it happens due to waveform. The best example is solar radiation. That is why the Stephen Boltzmann constant, who invented this radiation before the decade, he notified the equation for the emissivity which is equal to sigma T power 4. Sigma is the Stephen Boltzmann constant. So these three modes of heat transfer is very essential before going to study the course of heat and mass transfer. And these three modes of heat transfer belong to the heat transfer. So the law associated with conduction is Fourier law of heat conduction. The law associated with conduction is Newton's law of cooling. The law associated with radiation is Stephen Boltzmann constant. So with this, I conclude today's lecture. We continue next session. Thank you very much.